Good afternoon, or good evening, I should say. Thank you for coming to IND322, Redefining Operations with Caterpillar's Geospatial Intelligence Solutions. I'm Steve Blackwell, and I lead our product engineering and services team at AWS, which covers the solution areas of product engineering and smart products and services for automotive and manufacturing. And today, it's a pleasure, having started my career as an engineer at Caterpillar, to be co-presenting with Ash, Alan and Sriram, who are going to come up on stage later on talking about their geospatial intelligence solution. So what do we have for today? So I'm going to start off, and I just want to give a brief kind of background and overview of how we talk about smart products and services at AWS, and how we help manufacturers kind of build their smart products and services, solutions on AWS for their connected products and kind of the capabilities around that. At that point, I'm then going to hand over to the Caterpillar team, who are going to go through a little bit of an overview of Caterpillar Inc. themselves, and then go into a little bit of a deep dive around the Cat Helios, Caterpillar's digital data platform. Talk about their construction customers' problems and how they take advantage of the capabilities that Cat Digital have been developing. Then they're going to go in to talk about Cat Grade, and then finally we'll finish off talking about VisionLink. Okay. So with that, let's start and kind of talk about smart products and services. So when we work with manufacturers, smart products and services cover a broad kind of area, and we break this down into three pillars: consumer, commercial and industrial. Consumer is anything from a robot vacuum cleaner in your home to a smart plug. Commercial, anything from a printer in an office through to a HVAC system in an office building. And then finally, industrial, everything from a Caterpillar mining truck right through to a robot on a shop floor. But across these three areas, we really see kind of a common pattern of what manufacturers are wanting to do with their products. The first one is be able to have it connected. And once that connectivity is there, it then allows the manufacturer to then start, providing additional capabilities on top of that. The first one's around kind of, when you see this as a journey, around data and analytics. So once that product's connected, they can actually understand, how that product is actually operating and being used kind of out in the field. From there, we see, manufacturers then go, now they understand how that product's being used. They've got a little bit of kind of data analytics around use cases like condition-based monitoring. They can then start applying, AI and ML on top of that data set to start providing kind of insights. A prime example around a product is around predictive maintenance, for example, or condition-based monitoring. But it's not just around kind of, the data. We also say manufacturers looking to say, now that product is actually connected, it allows them to really focus on the customer experience, because it allows them to understand how their customers are using their product, and they can actually start linking, the telemetry data, the event data, the usage data of that product to their, their customers' insights, either through their service management portal or through their sales team or their field service teams that are actually out with the customer. So they can actually start developing features and capabilities and start improving customers' experience of using their products. We're also seeing that products are evolving as well, and they're now starting to become a lot more software defined. Okay, so it's not just around the hardware and the IoT or connectivity platform around that, but really how they can actually start to provide more features and capabilities as software on those actual products themselves. So that's really enabling manufacturers to be able to add new capabilities to those products once they're actually out in the field, based on customer feedback, or being able to kind of uplift and up-level that product of how it's actually being used as part of new service packs, for example. And then finally, we're seeing manufacturers see, okay, now I've got my product connected. Now I'm offering all these different kind of capabilities around predictive maintenance or, customer 360. Can I actually change my business model? Can I go from, selling a product and offering kind of services, maintenance support packages to a product as a service and generating new kind of revenue streams or creating new business models? So that's kind of like the capability, but we very much see this as kind of a journey that manufacturers go through. A lot of manufacturers talk about product as a service, But they've really got to start kind of at the level one that we describe, kind of that connectivity, understanding those KPIs, being able to do provisioning, device management, device lifecycle. In some cases in consumer or commercial, a product may go through multiple different owners or be in multiple different sites or buildings, for example. So therefore that whole lifecycle management's got to be built into it. We talked about kind of analytics and AI and services, but this is really where we also see manufacturers kind of expand beyond kind of their IoT platform or their connected platform and start to integrate it into the aftermarket parts and servicing. Okay, so for example, if there's a lot of spare parts management as part of that actual product, how can you use the product's telemetry data to feed into kind of the service teams management of spare parts? So unfortunately, when there is a service event, either proactive or reactive, and that maintenance engineer goes out to site, they actually have the parts available in their van, in their truck, to be able to do the work on that. And then finally, as I said, product as a service. And this is really where, these new business models are coming in. Manufacturers are being able to offer kind of, SLAs around it, potentially, offer capabilities like zero downtime, outcome-driven kind of engagements. And as you see, as they go through that journey of 1, 2, and 3, we see increased value, being added, to the customer of using those products. And this is all really kind of enabled by what we describe as telemetry-driven X. And that X could be, parts management, service management, as an example, but really taking the telemetry from the product and actually being able to use it across the extended value chain of, a manufacturer's business. Okay, so what does this look like from a conceptual architecture point of view, from a smart products point of view? Obviously, Caterpillar guys are going to come up here and talk specifically around their architecture and go into details around how they've actually architected it. But this is really kind of our conceptual architecture of how we see, manufacturers build out their smart products and services platform. So on the left-hand side, obviously, we have the connected product, and that's going to need a secure, data ingestion of the data from the product into the AWS cloud. In most cases, this is done via, IoT, streaming kind of the telemetry, the events. In some cases, depending on where the product is, if it's like out in a potential remote location where connectivity may be not as reliable as you would have in kind of a city, there may be bulk uploads of that data, and that may happen directly via into an S3 bucket or maybe using kind of APIs based on the products determining what its condition is. Then within the actual AWS cloud, obviously that data is going to come into a data lake. And on top of that data lake, which is generally built on kind of Amazon S3, we start to build kind of those microservices types capabilities. Fleet management is like one key capability we see manufacturers build as part of smart products. Having remote control and remote management is a key one. Obviously, telemetry and event management is generally where most manufacturers start as kind of their main use case to actually drive and build out this platform. And then on top of that, they've got analytics and AI insights. And then finally, agents kind of come into this, especially when you start to talk about kind of, maintenance and so forth, identifying kind of an event or anomaly from the product. You're going to bring that into the telemetry management part. Obviously, the analytics and AI insights is going to determine, is that potentially a part failure or a service event? And then obviously those agents are really going to come in to actually orchestrate, creating the service management ticket for potentially an engineer or a customer support center to actually contact the customer to tell them that actually we would like to come out and we'd like to service your appliance or your vehicle or your truck or whatever that product might be. And then on the right-hand side, there's going to be multiple personas that are going to be interacting with this product platform. Obviously, there's a mobile application which the service engineers or the end users are going to be using. There's probably going to be some business intelligence kind of capability built on top of it to be able to understand, how the products are performing, typical usage of those products from a features capabilities point of view. And there's obviously going to be enterprise, application integration, the CRM system, the MRO system, for example. Okay, So I just want to touch on one thing, obviously, I talked about, agents as part of that platform, but really really starting to see manufacturers look at, okay, now I've got my products connected, how can I actually bring AI in to kind of enhance that product, and increase the customer's kind of experience of that. And we see kind of a couple of areas where we're really starting to see kind of AI really help in, products. First one is around kind of the product development, using AI in a machine-based, simulation, helping those physics-based simulations or designing the product, either the hardware, finite element analysis, or CFD, or in the software development, being helping the developers test, validate, and integrate their actual software. Obviously, we see assistants kind of coming into products and really helping kind of differentiate and innovate on that actual product and how it's being used, and starting to provide more of a personalized experience, dynamic UIs based on how potentially that person is using that actual product itself. Anyway, that's kind of a brief overview of kind of like how we see smart products and services, the types of use cases, and how potentially AI is going to start to be used more and more in smart products and services. And with that, I'll hand over to Ash.
Thanks, Steve. Good evening. My name is Ash Shah. I have responsibilities for sort of technology strategy and emerging technology, engineering technology in our space. Primarily, my team is responsible for sort of determining the what we need to deliver to meet customer needs. So before we get into the geospatial solution that you're all here to hear about, I want to give a little bit of a background about Caterpillar. If I can get this slide to work. Thank you. So most of you have probably seen Cat equipment as you've been driving on the highway or have gone past job sites. What you may not realize is that Caterpillar has a global footprint. We are a multinational company. We are a global leader in the equipment that is being built that is necessary for building the infrastructure that sort of powers our world. Our workforce, over 112,000 strong, exists over in 24 different countries in 140 different locations. Combine that with our extensive dealer network of 152 dealers operating in 190 countries. That allows us to bring together a broad range of expertise in construction, mining, engines, turbines, and locomotives. We also have millions of machines operating around the world on almost every continent. Of those machines, 1.5 million of those are connected. So from excavators to generators, they are all streaming data to our back office, and we then process that. So how does Caterpillar, a company with this kind of breadth, harness that data, analyzes it, process it? Well, that is sort of the beginning of our Cat Helios data platform journey. And for that, I'm going to hand it over to Alan to go into more details on that.
Thanks, Ash. Clicker works again. All right, I'm Alan Doty, as they introduced me earlier. I'm the Director of Architecture for Cat Digital. Digital is obviously a big buzzword. What we mean at Digital at Caterpillar is our customer and dealer solutions that enable them to be very successful. I'm going to talk about why we built Helios, and we'll talk a little bit about what we built, how we built it, and then also talk about the scale, and then I'm going to hand it off back to these guys to talk about one of the solutions built on top of it. Why we built it? Probably about in 2018 or so, we had just a potpourri of technologies that were deployed across all our digital solutions. We had Teradata, we had Cognos, we had Hadoop, we had Azure, we had everything, everywhere all at once. And we heard back from our customers and dealers, they were confused because all these different solutions gave a different answer to what my fleet was. What's my customer data? We didn't really have very good control of it. And we had another failed experiment with outside company that we usually try to go to solve some of our problems. So our EO got involved and said, okay, we're going to bring in somebody that's going to help solve this for us and actually bring in digital talent. And so I brought in our SVP, Augie Resnick, and he brought in a huge ton of talent. We set off to build this Helios platform, right? We want to be confident in the data. We wanted all of our digital solutions to use it. We wanted to be secure. We wanted to get all the market faster on those solutions, and we also wanted to improve our customer experience most overall, so that way we can make things easier. So a little bit of how we built this, right? So kind of from a logical architecture perspective, we're looking at, on the left-hand side with point A there, we've got all the data we need to bring in from the different sources. Enterprise sources like what we built, what we manufactured, those things are kind of easy, but once you got to our dealer and customer, that became very complex because we had 160 different dealers are their own businesses. They use their own system, so bringing in their service information of what they actually did to equipment was very complex, and trying to get through that. And then as Ash said, we got 1.5 million connected assets out there, so we had to bring all those assets in, and some of those assets and devices are probably made when I graduated college, which was a long time ago. So we brought those in, and then what we had to do was then bring in all that data and bring a single point of truth, right? What is an asset, right? What is a customer? What is a dealer? And since all those different pieces of information came from different sources, we had to bring those in. Then we had to bring in services. So we didn't want to just bring in a data platform and make a data lake. We actually want to build APIs and services on top of those. So that way applications can use them and not replicate the data. Next, we wanted to make sure that we had data analytics. We knew the power of the data wasn't just making the data available, but actually putting insights on top of it. And we built a large data analytics pipelines, execution, and training environment that we can actually run and build on scale. That was always our problem before. All the vendors couldn't scale to our problem size. Then we want to make sure it's secure to design, and of course we want to get faster market, and then we wanted to be able to make sure we control our costs. So what did we provide from a functional perspective? Like we talked about, from a data perspective, data was the first thing we had to get control of. We had to get control of the single truth with customer, dealer, service, parts, all those different types. We have over 325 data objects that we've created and we mastered. And those services are then the derived data on top of those. So we made sure that those derived services, that we could then build those APIs, events, notifications, those sort of things. We built over 340 of those. So that way I had one single source API that would give me what my fleet list is across all my commerce apps, my customer equipment apps, and all those. Then analytics. We deployed over 23,000 models, high frequency inference models, on-demand real time, and some, obviously you gotta have your ML ops training as well. And then onboarding. We heard it from our customers, our dealers the most. Onboarding a customer is very hard. It's not like the auto industry where we've got a VIN number and you have to go to the state and get your license, right? We don't know that. Someone could just say that I own this tractor. So we have to do that a lot more. It's very hard for us to do. So we had to do a lot of investment to get in there. But we've got 1.7 million customers on the platform. So by the numbers, we talk about the scale, right? So obviously we want to make sure we're highly available. That's one of the reasons why we chose AWS over some of the other cloud providers that we had. And then we have 296 million pipelines, running per month, 1.4 million API calls, and 50 billion data records per month as well. And just an example, this is all built on AWS for the most part, right? And just from an example perspective, 680 S3 buckets, 1K million there, 5.7 ECS, Dynamo, and gateways. And of course, there's tons of other services I didn't list on those. Those are just the main scale. And just to show you that it wasn't just a single database that we spun up, right? It's a very complex environment that you had to move because our previous people that tried to solve this before, they're like, oh, we'll just spin up one Elastic Cache cluster and one Elasticsearch, we'll be good to go. And we're like, no, that's not going to work for the domain and size of data that we have. So we have 1.15 petabytes of storage, 265 million lines of code, and 3,000 pipelines. And one of the happiest things we have is 125 applications onboarded. So that's both from a data BI perspective, as well as a digital solutions perspective that are web applications, things like that. And that's why I'll turn it over back to Ash and Sriram to cover one of the solutions that they built on top of the platform. Thanks.
All right, so we have Helios as our foundation. Now we want to start thinking about how do we help our customers solve some of their toughest challenges. I'm not going to read everything on this slide for you, but our customers have a ton of inefficiencies, both in the construction and in the mining space. As you can see from the data on the slide, there is a ton of opportunity where we can remove inefficiencies, remove waste. We want to use the Helios platform to get the data, get the analytics to say, how do we take what we have and help our customers solve some of these problems? So before we get into the sort of the geospatial solution, let's just talk a little bit about this, right? Construction customers are wasting 10% of their materials. A third of work is redone. And then eventually what that all leads to is that only nearly 3/4 of projects are late. Any one of you that's maybe built a house or gone through that have probably felt that pain. You've seen the inefficiencies that exist in the construction space. Now think about that on a much broader scale. Some of our big infrastructure projects. How many of you have driven down the highway and you've just seen barrels forever and you're like, how long does it take to update a road? It feels like it's way longer than it should be, right? Some of this is a result of these inefficiencies where there's just inefficiencies in the process. So what we wanted to do is build a solution that can try and at least attack some of these issues. One of our solutions is Cat Grade. Cat Grade is Caterpillar's integrated machine control system, available in a host of different machines such as dozers, excavators, motor graders, and pavers. Think of it like a smart assistant for heavy equipment. It helps the operator do cut, fill, and sort of pass with precision. So it's, you guys who have modern cars have like lane assist or auto braking. It helps the operator use the equipment better. This is sort of the same thing with Cat Grade. Cat Grade uses GPS, sensors, and onboard computers to continuously track the position of the blade or the bucket. It provides near real-time location of the digital design loaded into the system so you know how you're operating based on what you need to do. So, if you need to slope it by 3%, the machine can measure the ground terrain and be able to tell you whether you're above or below and then adjust the blade as it needs to. So in the cab, the operator gets this sort of feedback. It allows them to make adjustments, and in fact, it'll do some of that for them. And then every time the machine goes over a piece of terrain, that data is collected and then sent to the back office where it can be processed. Now, I explained that a lot. This video will sort of give you a quick 2-minute overview of Cat Grade in action. Hopefully this will make it a little bit clearer.
We're here at Carolina Cat's demo facility, and today we're going to talk about the D5 with Cat 3D Grade and VisionLink productivity.
We're going to show you the features of these technology systems and how they can help you do your work faster and more efficiently. We have a full 3D plan of this site, and we're using the machine to get the site to finish grade in the least amount of time possible.
Typically, we'd take a USB and load that 3D design onto the display, but with VisionLink productivity, we can actually remotely load the design in the cloud and then download it to our machine.
We can help reduce the number of trips to the job site by remotely managing designs as the plan changes and ensure the operator's on the latest and greatest plan. With VisionLink productivity, we can remotely access the machine 3D system to help the operator with the most efficient settings on board the machine and ensure that he's on the correct current design.
With Cat 3D Grade and VisionLink productivity, the site manager is able to manage multiple sites in a much more proficient manner. Now that Aaron has the file loaded, he's actually watching the display in the light bars. That's giving him cuts and fills and also horizontal alignment no matter where he goes on this project. We added another feature called 3D Steer Assist. Aaron will select a line and then the machine will actually move left or right so that blade tip stays on the focus line and gives him not only elevation but steering guidance to that line.
The benefits of Cat 3D Grade, it allows them to use automatics once they get close to grade to be more efficient, more productive.
With Cat Factory 3D Grade with VisionLink productivity, it will allow you to maximize the return on your machine investment and get your projects done quicker in order to make more money.
All right, hopefully that made a little bit more sense about what Cat Grade is. So a lot of that focus was the in-machine, what we call onboard systems, right? Helping the operator actually use the equipment. As was alluded to, and you may have seen that in the video, right? There was talking about VisionLink productivity. It's now under the VisionLink umbrella. But what VisionLink will do is it's the back office web component that combines with the onboard data that we're collecting to really make this solution viable for our customers and allows the back office to help the operator and make sure that they're working on the right information. One of the problems that we've seen with customers is that they work on old designs. Someone made an update, that update didn't get to the correct operator, he or she is now working and doing the wrong thing. This system with VisionLink in the background allows us to ensure that all the machines have the latest designs and are able to do it. What Cat Grade gives us is the ability to correctly measure our metrics, our volumes, make sure that the right amount of dirt has been moved. We can make sure that our surfaces are properly constructed, speeding up the job process, cutting down on waste, and cutting down on cost. Having the machines at the optimal blade settings and just doing the right amount of work improves our machine performance, and so that the ground is optimized for, and the machine is doing the best job that it can. And then because of all of that, because there is less waste, there is less damage to the environment, we have an environmental impact where the construction work has the minimal footprint that it can for sustainability. Now, what we now get into the heart of our geospatial solution is we have all of this data that's coming off the machine that now needs to be processed by our back office, the solution that we built on top of Helios, and that is our geospatial solution. And I'll hand it over to Shiram, who is our solution architect, to provide the technical details.
Thank you, Ash. Caterpillar is a stronger company, the stronger our digital solutions get. This was Agi, our Chief Digital Officer, in a podcast. I'm Sriram, Solution Architect with Caterpillar for the last 10 years. We look at how Caterpillar, being a huge manufacturing company, have been building good digital solutions for our customers to use. Let me ask you this. What is the single important factor that is needed for a business to succeed?
Cost efficiency.
Right? Anything else?
Reduce waste.
Mm-hmm. Those are right answers, right? So, but it's not the revenue, it's not the market share. Yes, but it's not quality as well. Not even innovation, right? But it's the customer satisfaction, right? That's the most important thing. At Caterpillar, customer is at the heart of everything that we build. So we'll look at how VisionLink, that is powered by Helios, is helping our customers succeed every day. Let's do something interesting. Can I ask all of you to close your eyes for a moment? Think of you being in a busy airport. Flights taking off, landing, moving in every direction. There is something that is controlling everything and keeping everything safe and coordinated, right? What is that one thing? Any guesses? I think someone said that. Yeah, airport control tower, right? That's the one thing that is actually keeping everything safe and coordinated in an airport. Similarly, in a job site, be it a construction site or a mining site, it's VisionLink that is keeping everything safe and coordinated, and making sure all our machines are actually working smooth and sane. VisionLink is Caterpillar's cloud-based solution that provides real-time visibility to what is happening in a job site. You can track fuel levels, utilization of every mission. You can schedule maintenance from the application, so on and so forth. You can actually track where my asset is, what is it actually doing right now. All those things are possible with VisionLink. With VisionLink, it's all about making the most out of the data that you are getting back to the back office. We understood what is VisionLink, right? So we'll look at top 3 use cases that our customers are using in conjunction with the in-cab solution that Ash was talking, that we have in our digital solution that are helping our customers. We are sitting in this beautiful auditorium, right? The surface that we are sitting on is flat. But if you look at a job site, a mining or a construction site, you are going to have elevation changes in them. So what we are doing is our in-cab solutions actually pick up the elevation as the machine is moving on the job site, and that data is transferred to the back office, and we can have an elevation profile that can be shown in the application, so that customers can understand what is the elevation profile of the job site that the machine is working on. That's one thing. And our machines actually move the dirt. They move the dirt from crest to trough and then move the dirt from troughs to crests as well. We call it as cut and fill, and the back office solution can calculate the cut and fill volumes. These two are critical parameters in our application, where you are able to understand the lay of the land, you know how the surface is in a job site, and you are able to calculate the amount of dirt that is getting moved over by our machines. This is the interesting stuff. So as you can see, our machines are sending the data to Helios, which is actually an upstream system for our service that is completely facading everything that is happening left of us. So it is just an upstream system. It is a black box to us, and we are getting the data from Helios piped into us. And once we get it, we are actually using a step function to parse the data. We have proprietary data formats that are coming in from the field, and we are parsing the data using step functions because we have multiple steps of parsing that needs to happen. Once we do that, we store it in Postgres with a PostGIS extension. We use that for storing our surface data. Apart from storing the data, we use SNS SQS fan-out pattern as well to do parallel processing apart from storing the data. So we use it for calculating the volumes. We also do elevation tiles that we are calculating and then pushing it to a S3. While we do that, and it is being obviously served from CloudFront to the end user, we are actually invalidating the tiles as we get surface of the data from the machines. For example, right? So you have a 1 foot by 1 foot data that is coming into the back office, and while we calculate if the elevation has changed, we would need to invalidate the tile and make sure that we are showing the right tile at the right location. So the bottom portion is pretty straightforward. You have the user talking from through the APIs, through ELB and a Fargate task. Apart from it, it is from the browser, he is able to actually download the tiles from the CloudFront. Pretty straightforward stuff. Now that we know the lay of the land, we knew that the surface has elevation changes and you are able to see the elevation profile. The to-be state surface, so for example, typically you will have a surface that is having crests and troughs, and then there will be a surveyor who will be surveying and then finding out how the to-be state surface needs to be. Let's say, for example, you are constructing an airport. You will need a flat surface at a specific elevation. That data is actually created by the surveyor, and then it is created as a design file, and that will be sent to the back office from the back office to the machine. Before that happens through Helios again from the application, so you can upload the design file and then you will be able to send the file to the machine or machines that are actually working in the job site. Before we send this into the job site, we are able to see the preview of the file. So what happens is that, let's say this, as you would have probably guessed, I can be a site manager working in Vegas. I'm probably working remotely, and then there is an operator who is actually operating the machine in, let's say, Peoria. While he does that, the file transfer happens remotely. And what we had seen is that these files, as I was saying, the surveyors use design tools to actually create them, and we do not have a way for anyone to have those softwares to visualize them. What we have brought in is a visualization capability where you can look at a design file in 3D format before it is actually sent to the machines. So this is a really critical feature. For example, right, so we had probably 12 months this feature has been in the production, and prior to that we had a lot of customer feedback where operators were actually getting wrong design files because the ecosystem is broken, and we had to actually fill in and then make sure we are allowing the users to send the right design file to the machines. This one does that. You will be able to rotate it into 3D, and then you will be able to make sure that you have the right design file that is actually being sent across. So this is on the application, and then this one is actually on the in-cab solution that we have. So you can make sure that this is the right design file, and then it is actually sent to the machine. And as I said, sending to the machine is happening through Helios. We use Helios to send it, and there were issues that we worked with AWS team to have a workaround circumventing the problems that IoT Core has. So these files are huge files, and IoT Core cannot support these big files. So we were working around doing some circumventing for handling those situations, and then we were able to make sure these files are actually transferred to the machines. This is again a microservice that we have for processing the 3D preview feature. So the user uploads a design file into a S3 bucket using a pre-signed URL, and then it kicks off a SNS SQS pattern into a parallel processing, where one is we are doing heavy lifting, processing the design file completely, and then storing the data into the PostGIS database. The second one is more of a lightweight solution where we are having the preview generation. So preview of the file and the actual processing are separated out, and one is going to be heavy lifting, and then the other one is actually kind of a lightweight implementation that we have, and it is also served from the CloudFront. So we generate the file and it is served from the CloudFront, and then the user is from the UI it is actually pulled onto the CloudFront. And we do have, as you have seen, it is having just-in-time forget tasks that are actually getting created for processing the files. So now that we saw that what is the lay of the land, and then I have the to-be state design, and the operator has got it and he has worked on it. Once he does that, what is the proof of completion of the work? So in certain geographies like Europe and Japan, you do have mandates from the government agencies for some submission of proof of completion of work, so that they are getting paid for. So our customers who are the contractors would be actually needing this for generating revenue for their company. So after they complete the work, you will be able to generate an export of the surface, and it is sent to the agencies. So we do have multiple plethora of format of files that we can generate from the surfaces, and we will be able to actually allow the users to download them so that it can be submitted as a proof of completion of work. So this is, as I said, the surface export completion is probably going to take a lot of time, because we are going to have huge amount of data that we need to parse from the PostGIS database, and then parse it and then create the format of file that the user is requesting. So that being the case, this is an asynchronous process that we are kicking off. The user creates a API request, and then it kicks off a asynchronous process, and we generate the file using a forget task again, and then it is actually stored in a S3 bucket, and we use a Lambda to actually trigger an email. So because it is an asynchronous process, though, the user gives an email and then creates an API request, and you are creating the file behind the scenes, it could take anywhere between 5 to 10 minutes based on the surface that he is selecting. So for example, 10 square miles of quarry or a mining data that you want to process from a surface standpoint, based on how long this surface has been stored for, we will be able to actually generate the file and then store it in S3, and the Lambda would be sending a pre-signed URL as part of the email. So that's kind of how the users get the email from which they can actually download the file. I will, and obviously we are looking at, we are actually using the bounce and complaint delivery tracking capabilities of SES. We were not having those, and we were actually struggling to capture how many are actually downloading and those kind of things. But now that we have these capabilities in SES, we were able to actually take care of those kind of things. I will hand it over to Steve for concluding the session. Thank you.
Okay. So hopefully that was some good insights into how Caterpillar and the Cat Digital team are building kind of capabilities on top of AWS, for their customers, around their products. And I really appreciate them coming here, sharing their architectures, their best practices, and how they've gone through this. And this is just kind of one example of a customer that is doing this on AWS. Other examples are, Unox, who are an Italian manufacturer of, kitchen kind of equipment. We have Heisenberg, a German manufacturer that do kind of printing presses. HP, with their industrial print presses, also have done this. So we have multiple examples of how customers are building their connected product platforms on AWS, and not just providing kind of insights in how those products are being used for that, but they're actually building services on top of that, as you saw with Helios and VisionLink, of how they can actually provide better experiences and better usage of those products to those customers. Okay. With that, I want to say thank you. I really appreciate you staying with us.